Hi, I'm Jamie Stewart and this is my video showing what I've done towards my major project this year. I'll be going through my work, evaluating it, and going in detail on how I got to the point where I am now. So to start with my literature review that I wrote talking about psychology that's currently used in the game industry at present. This was a very broad topic and I found out very early that this was going to be a difficult topic to go for. However, I believe that the work I have done towards learning and finding out the aspects of psychology in the gaming industry was done very well for such a broad topic. The review itself looked into the more well-used and studied forms of psychological theory and data currently being used in game design. These theories are stuff like operant conditioning in both the positive and negative sense, players emerging in the game, and how a player experiences flow in a game. These theories have been supported by both game designers in the industry and by psychologists studying the effects of conditioning and immersion and flow in other fields. I also found out that a lot of studies revolved around multiplayer games such as World of Warcraft and various MMOs and large multiplayer games such as Call of Duty. So when Fabric asked for proposals for a multiplayer game in the style of Left 4 Dead, I took the opportunity to fully commit to making a multiplayer game, since a lot of my research revolved around multiplayer games when talking about positive operant conditioning. Now that I've talked about the literature review and introduced myself, it's best to get on to the actual artifact itself. The game, which I've come to call Relic, is a 1 to 4 player wave-based first-person shooter, where the player defends an objective, which in this case is a large monument with 4 arches, using a variety of weapons and gadgets that can all be used to defend the objective from the fallen enemies, which in turn they get resources to build more guns and gadgets. It's providing the core gameplay loop. The players at the start will be given a standard rifle and some starting ammunition in order to make sure that they get started in the loop. The enemy wave structure is designed to get more difficult as time goes on. In this case, it is by simply multiplying the amount of enemies coming at the players per wave. So in the first round it's 1 enemy per spawn, in the second round it's 2 enemies per spawn, and so on. Now behind the scenes, the player character actually hosts most of the code the players will be interacting with throughout the game. The first, best and most interactable example is the weapons the player will be using, as well as the gadgets and the HUD system as seen here. In the video it appears as though the rifle is firing a bullet across the range as shown by it impacting with a small puff of smoke at the end of the range. However, behind the scenes, this is simply a line trace, with a particle effect being emitted at the end of the range wherever the target hits. This changes depending on the target. For example, if I shot an enemy AI, it would turn to blood. The line trace also grabs the information of the object it's hitting. So in this case, it is getting the information from the enemy AI and sending it back to the player. The player then uses this in the code to send the damage amount to the target it's hitting. This can be seen by the target currently losing health from the overhead bar. The method, as described for the rifle, is also used for the shotgun weapon, as shown here, by firing a line trace out of the end of the gun of the weapon. Though each line trace for the shotgun does less damage, this is made up for in quantity, so a lot more shots being fired out at a target. So the closer a player is to the target, the more chance of taking out that target the player has, than if they were farther away, in which case they'd have less chance of hitting the target, like in a real world shotgun. The shotgun fires out multiple line traces in the direction the player is aiming at. Each shot is randomly offset to within a range integer of wherever the player is pointing from the crosshair. This allows for it to look like an actual shotgun. The grenade launcher, the final one of the 3 guns I've included, is probably the most different from the other 2 weapons in design. Like a real-life grenade launcher, it fires a large grenade out of the end of the barrel, and then the grenade explodes. This means that the grenade launcher itself cannot use a line trace. Instead, it fires a physics-based object, in this case the grenade, out of the end of the barrel, allowing for the object to bounce around, hit walls, and even hit targets before it explodes. The grenade applies damage by exploding and then emitting a sphere trace around it. Anything caught within the sphere trace is damaged. This is done in the exact same way as the regular trace used for the other 2 guns, except in this case it's the actual grenade itself sending and retrieving the signal to grab the name of the target to see if it's valid, and then apply said damage to the target. With the explosion, it's indicated by a particle effect, much like how the regular guns use a puff of smoke to indicate that they've also hit the target. When designing the weapons for the game, I started with the most straightforward approach, which in this case was the grenade launcher, as it fired a physics-based projectile, which I have done previously in Unreal Engine 4, with the only difference being that it needed to be replicated and sent to the other clients and the server. From there, I simply experimented, changing out the projectile and the spawning action with it making a line trace action and retrieving information based on the hit output of the line trace node in Blueprint. Once I got that working, I made the rifle and tested it out, finding that the line trace was very hard to replicate across all the clients and the server. I remedied this by putting the variables through the replication like I did previously, in which case I worked on the shotgun by simply adding a loop before the line trace, meaning that whatever the max on the loop is, it would spawn that many line traces. This addition, alongside a random range, allowed for a scattershot effect, as I've mentioned previously. The main issue, however, was getting everything to sync up. This meant the animations, the location of the characters, the rotation of the characters, and what the characters were doing, as this isn't a standard feature in Unreal Engine 4, and simply doesn't work normally. So what you have to do is you have to replicate everything, variables and otherwise. However, this doesn't always work in the case of the animation, and it needs to be synced. So you have to get the value of the rotation, put it into the server, and then multicast it back out to the clients in order to make sure everyone has the same page. Looking back at the situation, with syncing up all the players, it seems relatively simple. However, at the time it was extremely hard, with the main issue being to try and find where the problem was. As it stands, it was a simple matter of replication. However, how the replication was performed depended on what you were doing. So, for example, with the line trace and the weapons, it simply just needed to be replicated through the variables. So you send it to the server, then you send it out to all the players. Simple as. But in the case of the spawn actor for the grenade launcher, it needs to not be replicated, but instead the actual spawning action replicated and the projectile itself to be a replicatable actor. So this means that it shows up on everyone's server no matter what. Then, after getting the weapons set up, I started off on the gadgets. There were 4 gadgets in total in the game so far. The turret, which is a placeable pawn that allows for the players to place a turret that then goes and shoots enemy AI that comes within a radius. Yes, it doesn't require any additional input after that. However, once it runs out of ammunition, or it's shot enough times, it despawns and gets destroyed. Then there's the shield, which is simply a placeable actor with a health bar. This actor allows the player to hide behind it as cover, while once it takes so many hits, it simply despawns and the player has to put down another if they wish to remain in cover in their location. Then you have the placeable mine. The placeable mine is essentially the exact same as the grenades launched from the grenade launcher, except in this case they are triggered through proximity, not by a timer. And the last one is the health pack, which when a player simply walks over it, they will get full health instantly. However, the player cannot simply remain on the health pack in order to keep gaining health perpetually. They must go off of it and then come back on in order to regain health once they've lost it. For the gadgets, I started off with trying to make the health pack, which proved difficult, as the original idea was to have it as a simple pickup. And as it developed, it became more than that. It became a dispenser, more than just a placeable item, that could be used multiple times by multiple players. This meant I had to sync up all of the values, including how many more times that you could use it, and how many units of health it could give the player. This meant that if it wasn't synced up correctly, there'd be a lot of glitches in the game. For example, players getting more health than other players could see, enemy AI walking over it and gaining health, and so on and so forth. Next, after going through all the hassle of getting the health pack to work, I decided to do something a bit more simple and straightforward. The shield and the mine. Now, both of these were pretty straightforward. The mine had already been made using the physics projectile from the grenade launcher setup I made earlier, and just required a little bit of a coding change, while the shield simply required for an actor to be spawned that would stop a line trace, which is very easy to do in UE4. Though, not to forget the final gadget, and probably the most difficult one to make, the turret. The turret, as I said before, was a placeable pawn. However, originally it was just to be an actor. I believed that, given my past experience, I could make a turret using just the standard blueprint actor. However, this was quickly proven to be a futile attempt, as the turret simply would not work in a multiplayer setting. It kept coming across glitches after glitches and was juddering and basically breaking the game. So I decided to make it a placeable character that couldn't move and simply turned to face targets. This means that it had to have its own AI to be inputted when it spawned into the world. And meaning I had to give it a behavior tree, which was pretty simple, to be fair, as I was working on the enemy AI at the time. And simply salvaged parts from the enemy AI design and placed them into the turret AI design, allowing for the turret to basically act like an enemy AI without the movement. As I have previously mentioned, most of the code goes through the players. And for the crafting bench, this is probably the most vital. Each crafting bench only shows what that player is doing on your screen. So if you're player 1, you only see what player 1 does. If you're player 2, you only see what player 2 does, and so on and so forth. Meaning players can't peer over your shoulder and change what you're doing on each crafting bench. Now, there are 3 different crafting benches you can have. The ammo bench, the gadget bench, and the weapon bench. Each one pretty self-explanatory. The ammunition bench gives you ammo, the gadget bench allows you to get gadgets, and the weapons bench allows you to make weapons, as I said. Each bench only displays to the player interacting with it. So if you have a grenade launcher up, another player can come by and go, "Ooh, I want a rifle," and scroll down and get a rifle without interfering with your instance of the game. The crafting benches also show you how much of each resource you need to create each item, allowing for the player to browse casually through each of the benches to see what they could make with the amount of resources that they already have on them. The crafting bench also acts as the reward portion of the core game loop, with the enemy AI acting as the obstacles that the player must overcome, and the weapons and gadgets acting as the tools to overcome said obstacles. So, the player simply gets gun, shoots enemy gives reward, use reward to buy more guns, rinse and repeat. The crafting bench also allows the players to regain ammunition, as I said before. This is the core loop, and goes back onto what I've said and learnt during the literature review. This is a positive conditioning loop, with the players being rewarded with more resources to make more weapons in-game by performing an action, in this case, killing AI. This is also found in the opposite sense as well. If the AI overpowers the player, or the player does something stupid, they'll die and respawn, allowing for enemy AI to reach the objective, which eventually leads in a game over, which is a negative condition and a negative outcome, meaning that the player will less likely allow for it to happen again and continue playing the game as it was designed. Now, since I just started talking about the core gameplay loop, I should really start talking about the main obstacle, the enemy AI. Now, I've never worked on AI in Unreal Engine 4 before, so I found this a very steep learning curve, yet very rewarding in the end. Like I said with the turret design earlier on, I was working on this and tinkering with it after I'd just finished with the weapon and the basic character setup. The enemy AI I had originally intended to make was a lot more complicated and advanced than I had originally thought at the beginning. So I decided to research and study into how to make AI in Unreal 4 using the behavior trees. By study, I mean tinkering and fiddling around with the code a lot. I ended up getting a good grasp of the basics of the behavior tree and the coding and blueprints that went into making the various parts of the tree, eventually making the AI you see in the game. This AI is able to follow nodes that are placed at random points throughout the map. These points and nodes allow for the AI to make a path around obstacles and towards the main objective. If the AI sees a player, it will stop going for the objective and start making its way towards a firing distance to the player. So it'll get within a range and start shooting. Or, in some AI's case, they'll try and get around the player quickly in order to basically shoot them in the back. After which, they'll either die and eject loot for the player to grab, thus adding to the core gameplay loop, or they kill the player, in which case they will simply go back to their main objective of either hunting down closer players or heading back to the main objective. The enemy AI, however, was extremely difficult, because in order to replicate it across the various different players, as across each instance of the game, you had to cast the location, rotation, position, and the health bars of each individual AI character to all of the players. Now, at first, I believe this was quite simple. I'd managed to test this out with a single enemy AI, and it worked fine. Until I introduced waves. Once I introduced the spawn manager in order to make multiple waves, things started going wrong. The game started making hundreds upon hundreds of AI, and essentially killing the game's frame rate for the clients. The server, however, could keep up with it. So I went back to the drawing board. I changed things around and reconstructed the server manager to make smaller amounts of the waves than I'd originally intended, as well as going back to the enemy AI and making it more streamlined and a lot more, well, efficient on the processing power. This means that now it can process a more fair amount of enemy AI rather than what it was before, allowing for the game to be working properly and be able to run on the client side as well as the server side for all the different players. And so, in a final conclusion, I believe what I've presented today here on this video shows what I had originally thought of back at the beginning of this entire project when I presented the elevator pitch to Fabric. Though it is not everything that I dreamt it would be, it still demonstrates and presents the original pitch and ideas effectively, and in a way that it could be played by anyone and understood. Pretty much all of the bugs and glitches that I originally encountered while making this game have been removed or are no longer happening, based on my coding and my efforts. The steep learning curve has given me a brand new affection for AI and its management in the behavior tree for the Unreal Engine 4, and will probably mean that I'll look into it more in the future. The project itself also uses a lot of what I learned during the literature review. Operant conditioning is a heavy point in game design, and after having learnt it, allowing for me to understand how to positively keep the player playing and let them learn how to play the game using positive feedback and negative feedback in order to create positive conditioning and negative conditioning scenarios. Personally, I hope to develop this project further in the future and in my own spare time, and maybe even make it a fully fledged game and not just a demo. Thank you very much for listening. This is Jamie Stewart, and this is the end of my video.